You type int an interface in a constructor, never mention a concrete class anywhere, and somehow Magento hands you back a fully built object that implements it. No factory call, no new keyword, no service locator you can see. Today we open the real source behind that trick, the di.xml configuration file, the object manager interface, and the config class that actually resolves a preference and trace exactly how an interface name turns into a real instance. Welcome back to Magento Development Deep Dive. Part 2 covered how a module gets noticed at all. Part 3 goes into the mechanism every single Magento class relies on afterward, dependency injection. We're going to read the di.xml schema Magento actually ships, the object manager interface every implementation honors, and the config class the unglamorous array juggling code that turns a pile of XML into runtime decisions. Everything on screen is pulled straight from tag 2.4.9 of Magento/Magento 2, same commit as the last two parts, so you can open the identical source yourself. By the end of this part, 5 things should click. What a preference element in di.xml actually does to the object manager's internal state. How type arguments and virtual types differ from just injecting a plain class. What the object manager interface guarantees every implementation of it provides, no matter which one Magento is running. How the config class's getPreference method resolves an interface down to a concrete class name, safely, even when preference is chained through several layers. And how dozens of di.xml files scattered across modules get merged into one coherent configuration instead of quietly overwriting each other. Strip away the reflection and constructor argument plumbing, and dependency injection in Magento is 5 stages. Declare, a module's di.xml file states a preference, an interface mapped to a concrete class, or a type with specific constructor arguments. Merge, config : merge configuration folds that module's declarations into the same shared arrays every other module's di.xml also writes into. Request, somewhere in application code, the object manager's get method is called with a type name, almost always an interface. Resolve, config : getPreference walks that interface through the preferences array until it lands on a real, instantiable class. And instantiate, the object manager builds that class, resolving its own constructor arguments the same way, and caches the result if it's shared. 5 stages, and we're opening the real source for everyone. A few things help before we dig in. Either a real Magento 2.4.9 checkout, or just the GitHub tag open in a browser tab, so you can follow the file paths as we go. Comfort reading XML and basic PHP class syntax is enough. You don't need to already know a dependency injection framework. Part 1, on the boot sequence, and Part 2, on the module system, give useful context for where di.xml files live and when they get read, but neither is required to follow this one. This is a real preference block from catalog's admin area di.xml file. Each preference has a for attribute, an interface name, and a type attribute. The concrete class Magento should actually build whenever that interface is requested. The first line says, whenever anything asks for the handler interface, hand it a composite implementation instead. The second does the same for a locator interface, resolving it to a registry locator. Neither consumer of these interfaces ever names composite or registry locator directly, they only type hint the interface, and the preference is what closes the gap. A type block is different from a preference. It doesn't redirect an interface, it configures a specific class's constructor. Here, whenever the object manager builds catalog's admin attribute controller, it injects the translate cache type as the constructor argument named attribute label cache. That controller's own constructor just type hints a cache interface with that parameter name. It has no idea which concrete cache type it's getting until this argument override in di.xml tells the object manager exactly what to plug in. A virtual type is one of the more surprising di.xml features the first time you see it. This declares a brand new type name, product collection factory, that has no corresponding PHP file anywhere on disk. Instead it says, whenever this name is requested, actually build the real collection factory class, but override its instance name argument to point at a specific product collection. It's a configured variant of an existing class, created entirely in XML, and it's how Magento avoids writing near duplicate factory classes for every collection variant it needs. Plugins, which part 4 of this series covers in depth, are declared inside the exact same type element as constructor arguments. Here, the full category product reindex action gets a plugin that invalidates the page cache afterward, and the attribute resource model gets one that does the same after an attribute save. Preferences, arguments, and plugins all live in this one di.xml vocabulary. The object manager's configuration merging doesn't treat them as separate systems, just different keys under the same type. Whatever object manager implementation Magento is running, it honors this exact interface. Create builds a brand new instance of a type every time you call it, taking optional constructor argument overrides. Get returns a cached, shared instance if one already exists, building it only once. And configure is the method http:// called back in part 1, feeding in merged di.xml configuration preferences, arguments, plugins so the object manager knows about it before resolving anything. This is the method that actually answers the question we opened with. GetPreference takes a type name, strips a leading backslash, and then loops. As long as the current type has a preference registered, it follows that preference to the next type. The elided block in the middle throws a logic exception if it ever detects a circular preference, one interface preferring a second that eventually prefers the first back, which would otherwise loop forever. Once no further preference exists, whatever type name is left is the real, instantiable class the object manager will build. And this is where every preference element from every di.xml file across the whole system ends up. Inside _merge configuration switch statement, the preferences case iterates the for to pairs parsed out of XML and writes each one straight into the same _preferences array that getPreference reads from. Notice there's no per module namespacing here, it's one flat array, key by interface name, which is exactly why two modules declaring conflicting preferences for the same interface will have one silently win based on merge order. Constructor arguments merge the same recursive way. _collect configuration checks if the requested type is actually a virtual type, and if so, recurses into whatever real type it's configured against first. Otherwise, if the type has parent relations, meaning it extends or implements something Magento already has arguments configured for, it walks up that relation chain, in the elided loop, merging each parent's arguments in before applying the current type's own. That's how a subclass automatically inherits di.xml argument configuration from everything above it, without redeclaring any of it. A few things trip people up here. If two modules both declare a preference for the same interface, there's no conflict error. Merge order decides which one wins, silently, and that order depends on module sequence and load rules covered back in part 2. GetPreference throwing a logic exception on a circular preference is rare in practice, but when it happens it halts the entire request, not just one class. Virtual types are a classic time waster. The first time you hit one, searching your file system for a class file that matches the virtual type's name will fail, because there isn't one, it only exists as configuration. And constructor argument overrides in di.xml are matched by parameter name, not by type. Get the argument name wrong and Magento silently falls back to whatever the constructor's default is, or throws, depending on whether one exists. Let's pull dependency injection back together. A preference element redirects an interface to a concrete class, globally, for the whole application. Type arguments and virtual types let you configure how a class gets built, or invent a pre-configured variant of one, without touching that class's own code at all. Every Object Manager implementation honors the same three-method contract: create, get, and configure. Config::getPreference is the method that actually walks an interface through the preference chain until it lands on something instantiable. And critically, every di.xml file from every module in the system merges into that same handful of shared arrays. There's no per-module isolation, which is exactly why understanding the merge order matters as much as understanding any single file. That's how Magento actually resolves dependency injection, straight from the pin 2.4.9 source with every file and line cited. Part 4 goes straight into plugins, the before, after, and around interceptors we saw declared in di.xml today, and exactly how Magento's interception chain calls them in order. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 4.